Dear student, welcome to ACE Online, digital platform of ACE Engineering Academy. So this is Dr. G. Balaraju on behalf of Mechanical Engineering Department, and my colleagues are there to present solutions for memory-based questions in GATE 2023 Mechanical Engineering. So we received a few questions from students. So we are not sure about exact data. So based upon only memory, we are trying to present the solutions. So it's only for your idea's sake we are presenting. So my colleagues, my friends will explain the solutions for available data. We're not sure about the solutions. So coming to paper, the paper is moderate to tough. I cannot say easy. So few unexpected questions like different areas. I cannot say those are very tough questions, but unexpected questions like mechanics, engineering mechanics and material science. And a few questions are very lengthy, so you are able to manage in less time. But since you have not focused such kind of areas like now new areas, so there is a chance of getting some confusion. So coming to weightage analysis, so you can see the title wise, the topic wise weightage, manufacturing like a production site. So there are 3 1-mark questions, 8 2-mark questions. So compared to previous question papers like a 2022 and 2023, just we're comparing. In 2022, only hardly 5 questions, 2 marks, but in 2023, so more weightage for production. And coming to thermal engineering, generally 5 questions, 1 1-mark question and 4 2-mark questions. Heat transfer, so 5 marks. So compared to previous papers, just 2 marks less. Fluid mechanics, 9 marks, so highest weightage for fluid mechanics. Because generally we may get 7 to 8 marks, of course, the same only. Theory of machines, less weightage compared to previous question papers. Like a 2022 paper, if you see, almost 8 marks from theory of machines. So this time, we had only 2 plus 2, 4 marks. Strength of materials, highest weightage this time. 3 questions from 2 marks. and 1 mark questions 4. So 6 plus for highest weightage for strength of materials. And machine design, same weightage of course. So previous question papers also 4-5 marks, this time also same. IM and OR this time disappointed, only 2 marks from IM and OR, so previously 8 marks. So it's only based upon the memory we are presenting. We are not sure exactly what the questions were, like from where we had the questions. Based on your feedback, like many students, they sent only the titles. They're not sure about the content. Engineering mechanics. So two questions of 2 marks and 1 question for 1 mark. Engineering materials, highest weightage. Okay, generally we get only 1 or 2 questions, but this time almost 5 marks from material science. Engineering mathematics and 13 marks and aptitude as usual. So overall, if you see, the paper is like based upon students' feedback. A few people are saying that very tough, and a few people are saying that moderate. I cannot say easy, so moderate to tough. Like based on your questions and based on students' questions, we are presenting answer. We are not sure about the values, so numericals. So my colleague will continue. So I call Madhushekar for presenting solutions for material science.
Right. See here, I'm going to discuss some of the memory-based questions from this material science subject. If we talk about this material science subject, the questions are easy to moderate actually. One question asked from iron cementite phase diagram, especially lever rule question. Another question asked from strain hardening mechanism, that is power law. And third type of question is asked from calculating density of the material, especially from the crystal structure. Let us consider this iron cementite phase diagram question. We don't know exactly this is 2 mark or 1 mark, but here based on the given, based on the type of question I am deciding, this may be a 1 mark. This is actually a 1 mark and this is 2 mark and this is also a 2 mark, right? So let us consider this. I frame a question based on the data I got from the students. What data I got, from the student? They said the percentage of carbon is 1.5% of carbon, and they said calculate the ratio of mass fractions of proteoctide cementite to total cementite. So based on the given data, I frame a question, and I am going to give the solution here. Okay, this is related to iron cementite phase diagram. So the question maybe they framed in GATE exam, how they framed, at 1.5% of carbon. See, 1.5% of carbon alloy is cooled from liquid state to, just below or up to eutectoid temperature, right? And they asked the ratio of calculating the ratio of mass fraction of proteoctide alpha to the cementite, right? So first, let us consider, I'll calculate pro-eutectoid cementite. First I'll calculate pro-eutectoid cementite, right? So this pro-eutectoid cementite, how will you get? By drawing the lever line here, by drawing the lever line, see here, the lever line is this one here, okay? This is C0, this is C perlite, this is C cementite, 100% of cementite you'll get. So the lever line, here it is, the lever line, here it is, this is C0, listen carefully, C0, that is 1.5% of carbon, C perlite, that is approximately I'm taking here 0.79% of carbon from the textbook with the reference. Maybe in the question paper, maybe 0.8 sometime, 0.76 also sometime they'll give. And here cementite is 6.67% of carbon. So if I want to calculate mass fraction of pro-cementite, right, the lever line formula is, cementite is present that side, so C0 minus Cp by C cementite minus Cp, that is 1.5 minus 0.79 by 6.67 minus 0.79. So by solving this, you will get mass fraction of pro-cementite. So I calculated this by using the calculator, so 0.1209 I got approximately. And second, mass fraction of total cementite I want to calculate. So at this same point, mass fraction of total cementite if I want to calculate, this is the lever line. This is C alpha, this is C cementite, right? So this is the total lever line. So let us consider this one. This is C0, that is equal to 1.5% of carbon. This is alpha, C alpha, that is equal to 0.025% of carbon. This is cementite, C cementite, that is 6.67% of carbon. Right, mass fraction of total cementite if I want to calculate, so from the lever line, that is C cementite minus C0 minus C alpha. This is C0 minus C alpha, okay, C0 minus C alpha, because cementite is this side, by C cementite minus C alpha. Right, from this 1.5 minus 0.025 by 6.67 minus 0.025. Right, 1.5 minus 0.025 minus 6.67 minus 0.025, you will get 0.221, 2219 or 79 like that, etc. Now the ratio they are asking, mass of pro-eutectoid cementite by mass of, right, total cementite they are asking. So from this 0.1209 by 0.2219, approximately you will get 0.5 or 54. This is the answer. Right, this is the answer. This is somewhat complex, most of you people may not get, but easy one. And the second question is very, very simple question. In the question it is asked theoretical density, and in the question it is given FCC unit cell, right? So FCC unit cell, number of atoms in the unit cell is 4. Relationship between R and A, 4R is equal to root 2A. So from that, calculate volume of unit cell, that is A cube, that is 4R by root 2 whole cube, right? And then theoretical density formula you are familiar, that is a basic standard formula, effective number of atoms into atomic weight by Avogadro's number into volume of unit cell. Now here the number of atoms 4 and atomic weight is given in the question, that is 60 grams per mole, 60 by Avogadro's number is given 6.023 into 10 power 23 into volume of unit cell, that is 4R by 4 into 0.1 into 10 power minus 7 nanometer, that comes into centimeter, by root 2 whole cube. By solving this, you will get the answer. Right, that's a basic standard question, very simple question. Approximately you will get 7.62 grams per cc you will get. This is the question, theoretical density question. Based on this formula you can solve. And last question, this is actually from the strain ordering mechanism. So in the question, power law of strain ordering is given, and they are asking calculate engineering stress at ultimate point. One important thing you should remember, at maximum stress at ultimate point. Remember, at ultimate point, epsilon t equal to n, we already discussed, right? Epsilon t equal to n, we discussed in the class and online also, right? So online, like deep learn program also, right? So from this, epsilon t equal to n equal to 0.3. By substituting, you will get sigma t equal to 400 into 0.3 power 0.3. You will get sigma t. And also epsilon t is equal to 0.3 is equal to ln 1 plus epsilon e. Calculate epsilon e from this, right? Calculate epsilon e from this, and finally sigma t is equal to sigma e into 1 plus epsilon e, right? So sigma e is equal to engineering stress at the ultimate point is equal to sigma t by 1 plus epsilon e. By solving this, you will get the answer. Now here sigma t will get approximately 278.73 megapascal by using calculator, and epsilon e is you'll get 0.3498, and by substituting these values here 206.49 megapascal, you will get the answer, right? So these are the questions, especially from the material science. Questions are moderate, right? Next, our colleague Fasikan sir will take care of this production.
you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make ACE online platform as a part of your success story. ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make ACE online platform as a part of your success story. ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make ACE online platform as a part of your success story. ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success.
Right, 1, 2, 3, right?
Yes,
Ready.
you rightly heard it.
Chalo, right. Once again, so this year, again as expected, from the production engineering, huge number of questions and huge weightage was there. Around 19 marks were there only from the manufacturing technology. When you look at the questions, as a lengthy questions we have, and from the machining topic especially 2 questions were there, which are very lengthy, as I got feedback from the students. Whereas if you notice, this is orthogonal machining related question where in this question, again very big data was there, but at the end only given data I took, and then based on given data, whatever they are asking us to calculate, that particular thing I take on this particular slide. Whereas the value of shear strain rate they are asking by providing the shear angle, cutting speed, this is actually a rake angle, and then shear plane thickness is also provided, that is 25 into 10 to the power of minus 6 meters, and they are asking a shear strain rate, whereas shear strain rate epsilon naught we used to discuss as a shear velocity by shear plane thickness. Even we used to write this particular formula in terms of cutting velocity also, as they provided a cutting speed or cutting velocity. So we know in terms of cutting velocity it is a V cos alpha by Y cos phi minus alpha. So those who are able to recollect this particular
formula for the strain rate, then easily by substituting the values, like V is provided as 1 meter per second, whereas cos alpha is a 5 degree by Y is provided as 25 into 10 to the power of minus 6 meter into cos 5 minus alpha. 5 is given as 45 degree and then alpha is given as a 5 degree. So just if you need to, if you calculate this particular value, you will end up with an answer. I think it's a MCQ also, whereas options are there, 2-mark question. So from the options easily you are able to get the answer. I think it was something around 5.2 into 10 to the power of minus 4 or minus 2, something like this, per second was the answer they given in the options. Right? Memory based question, just I try to show you based on formula how you're able to solve this question, where strain rate calculation in orthogonal machining, if you're able to recollect, then easily you're able to tackle this question, where the single point orthogonal machining tool is engaged, where every shear plane is of a constant thickness we take, and after that we do the analysis. Along all the assumptions of orthogonal machining, we include Pispanin's theory, where every shear plane is of constant thickness. Based on that, we are able to conclude towards this strain rate calculation. So this is one question which we are noticing this year. Then after this, even in our metrology, there were 3 marks were there, but one question which is asked from the interferometry, again lengthy question, but in that interferometry, as I am giving brief idea, if you look at here, in the interferometry what they ask is, by using a monochromatic light, they are asking us to calculate a height difference in between 2 slip gauges. So delta H is equal to G by L into N lambda by 2. Those who are able to recollect this particular formula, again every data is provided, whereas both slip gauges are having a constant face width value and distance between slip gauges were given, and fringe spacing was given, number of fringes were given, and wavelength is provided. So by substituting those particular data, directly again you will get the height difference of a slip gauges. By standard 1 slip gauge, directly they are asking a height difference, so simply substitute that value. Again lengthy question it was, actually this question was copied from GATE 2013 paper. If you go and check IIT Kanpur old paper, directly the same question it was, just by changing the data, by changing the figure, there was one more question for the 2 marks from the metrology. Like this, few more questions were there. After we are getting directly question paper, we will release the entire detailed solution in our ACE Academy website. Thank you. So next remaining questions will be continued by my colleague Ravi sir.
Whatever may be your present circumstances, But if you determine
Hello
for your
student, just see
success,
they asked very easy resistance welding
yes,
questions.
you
Simple,
rightly
one
heard
formula
it.
is there.
Ace
What
online.
they asked, resistance spot welding of 1.5 millimeter thick, just thickness is given, that is thickness is 1.5 millimeter, 1.5 millimeter sheets. You can see the current is also given, that is 10,000 RPM, ampere. I am writing the current is 10,000 ampere. Then for a 0.25 second, the time is also given 0.25 second, that is tau is 0.25 second. The contact resistance is also given here. You can see the value of R. This is the value of R. The volume of weld nugget formed after the welding is the volume is given in millimeter cube. Unit has importance. This volume is 70 millimeter cube. The thermal efficiency of the welding process in percentage. Very simple formula of thermal efficiency is there. Then I am writing here the efficiency is equal to heat utilized or heat required divided by heat generated. What is the heat generated here? It is I square R into tau, and you can see that in this numerical the value of current is given. You can see the resistance is also given. Here you can see the resistance and the time is also given. Then we have that whole term, that is I square R into tau. And what about the heat utilized? Here you can see that the simple trick, the volume is given. Volume is given 70 millimeter cube. Then we can write here the volume into HR per millimeter cube. Now I don't know the correct data because here the value of HR per millimeter cube is not given. But I think this volume is, just I can put what is the volume is 70 into HR per millimeter cube. You can see we don't have now the value of HR per millimeter cube divided by I square, that is 10,000 square, into resistance is 0.0001. Yes, into time is 0.25. Either there may be HR per millimeter cube may be 70, it may be. Then if we have that value, we can put it there and we can calculate the efficiency. Very easy question, simple, one numerical is there. Now see, the next is also very easy. On the CNC machine they asked about the BLU, that is basic length unit. Now in that question, in the feed drive of a CNC drive, a stepper motor rotating 50 steps per revolution, one step is equal to 1 pulse. Hence here the 50 step means 50 pulses. 50 pulses. In the 50 pulses there is a 1 revolution, 50 steps per revolution, 50 pulses per revolution means in the 50 pulses there is 1 revolution of motor shaft is equal to 1 revolution of lead screw is equal to this pitch. What is the pitch? 5 millimeter. Then I can write that in the 50 pulses the pitch is 5 millimeter. Then what about the in 1 pulses? What will be the value of basic length unit? Then simple, we can calculate the BLU is equal to 5 divided by 50. This is the answer. If the BLU they asked, but for 2 mark, if it is a 2 mark question, then definitely means I think that they will not ask BLU for the 2 mark, but some extra data may be there. But whatever the data may be there, first it is important to calculate the basic length unit, which we can calculate, that is 5 divided by 50 millimeter. Yes, I have this question only. If there is again some question, then I will again come to give the solution. Thank you.
Yes, you rightly heard it. Ace online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make Ace online platform as a part of your success story. Ace Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. Ace online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make Ace online platform as a part of your success story. ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE Online platform raises you much more than what you can think. This platform provides pre-recorded and online lectures which you can access around the clock. You can prepare for the various competitive exams like a GATE, ESC, PSUs and other state service exams, mainly in the English, Hindi and Telugu languages. Hope you'll all going to make ACE Online platform as a part of your success story. ACE Online. Learn anywhere, anytime. Wherever may be your present journey, but if you decided for your goal, whatever may be your present position, but if you opted to reach higher altitudes in the life, however may be your present duties, but if you choose to find the joy of working, whatever may be your present circumstances, but if you determined for your success. Yes, you rightly heard it. ACE Online platform raises you much more.
Good evening. I welcome you all to the analysis of questions based on memory for GATE 2023 Mechanical Department. I'll be taking the questions from Fluid Mechanics subject. Now, as far as whatever questions we have got and what data we have got from our students, we realized that the questions were rather lengthy but relatively easy compared to last year. Let us take one question that has appeared. This question, I believe, was appeared for 2 marks. This question is basically very easy but lengthy. The question over here is saying that you are having some gate. This, let us say, is a gate you are having. And in contact with this gate, you are having multi-layered fluid. The upper layer being, let us say, 1000 kg per meter cube density for 1 meter depth. The lower layer being a fluid of 2000 kg per meter cube density with 2 meter depth. The question asked over here is, there is a hinge present at the bottom, and what is the moment of this particular fluid's hydrostatic force per unit width on this particular gate about this particular hinge. Now you see, this question becomes difficult because you are having multi-layered fluid. And whenever questions become lengthy, what you are supposed to do is try to avoid calculation till last step. And that can be done now. The reason being, densities are given in the ratio 1:2. Let us say the upper layer is having a gamma value gamma, lower layer is having a gamma value 2 gamma then. So I can draw the pressure distribution diagram. It will come out to be a triangle and will come out to be a trapezium over here. This depth is equal to 1 and this depth is equal to 2. The density, the pressure over here is going to be equal to gamma times 1. The pressure over here will be equal to gamma times 1 plus 2 gamma times 2, that is equal to 5 gamma. That is equal to 5 gamma. If I take this particular point as some point O, let us say, the moment will be equal to how much? The moment over here is supposed to be equal to, if I take this particular force as F1 force and this force as F2 force, hydrostatic forces, and if I take this lever arm as H1 lever arm, and if I take this lever arm as H2 lever arm, the value of moment about point O is supposed to be equal to F1 times H1 plus F2 times H2. F1 times H1 plus F2 times H2. Now recall, the value of force when you are doing pressure prism approach is supposed to be equal to volume of pressure prism. And that is going to be equal to cross section multiplied to width, width being 1 unit over here. So the cross section of this particular triangle has to be equal to half base height, that is gamma times 1/2, that is equal to gamma by 2. This is the value of F1 we are having. The value of force F2 over here is equal to trapezium. Trapezium's area is equal to average of bases multiplied to height. The sum of bases is 6 gamma, divided by 2 is 3 gamma, multiplied by 2 is 6 gamma. Therefore, the value of F2 is equal to how much? 6 gamma. Till here, it should not take a lot of time for you. Now, what will take time is the value of H2. The value of H2, one moment please. What should take time is the value of H2. Let us say H2 is the centroid of this trapezium. Now centroid of the triangle, you should be knowing that it is going to be 1/3 from the base for a right angle triangle. Therefore the value of h1 will be equal to, if you measure, you will get 7/3 meter. Now coming to centroid of trapezium, you can break down the trapezium into a set of two bodies, which is a rectangle and a triangle. And you can use a formula of h bar is equal to a1 h1 plus a2 h2 divided by a1 plus a2. If you know the formula directly, it is good for you. If you do not know the formula, you'll have to spend some time. As far as I have calculated, the value of h2 would come out to be 11/9, I believe, meter. 11/9 meter. Okay? Once I get this particular value, I can write moment is equal to gamma by 2 into 7/3 plus 6 gamma multiplied to 11/9. 6 gamma multiplied to 11/9. And if you put the value of gamma as 9.81, for water it is equal to 9.81, if G is given as 9.81 kilonewton per meter cube. So this value should come out to be nearly 83.4 kilonewton meter per meter. Kilonewton meter is for moment. Since it is per unit width, therefore per meter. The value should come, for whatever data we have got, I can say the answer is 83.4 kilonewton per meter, kilonewton meter per meter. If the answer is different, I can assure you the question also is different. Let's move further. The next question over here is a question which is basic Euler's equation, or you can say Bernoulli equation. The question says an invested 2D flow field in xy plane is defined as velocity vector is equal to k times xi cap minus yj cap, where the value of k being 2 second inverse. If the pressure at 0, 0 is equal to 100 kilopascal, find the value of pressure at 2, 2 if density is equal to 1000 kg per meter cube. I'm assuming the coordinates over here are given in meter. Okay, that only makes sense. The coordinates are given in meter. So now how do I find this out? I realize that the value of z, that is datum head, is remaining constant. That is, let us say, equal to 0, since it's a planar flow. So if datum head is constant and there is nothing mentioned regarding viscosity, I will assume Bernoulli equation is valid. Therefore, P1 by gamma plus V1 square by 2G must be equal to P2 by gamma plus V2 square by 2G. Plus V2 square by 2G. Now I have the value of P1. P1 is equal to 100 kilopascal. The value of V1, if I put over here 0, 0, the velocity head will come out to be equal to 0. If I put V2 as 2 times 2i cap minus 2j cap, that means my V2 vector will be equal to how much? It will be equal to 4 meter per second I cap minus 4 meter per second j cap. That means the magnitude of my velocity will be equal to 4 root 2. I don't have to explain you why. Okay? So V2 is equal to 4 root 2 meter per second. Now I can write over here, if I cancel of G throughout, I can write over here, the value of P2 is equal to P1 minus of rho into V2 square divided by 2. P1 is equal to 100 kilopascal minus of 1000 multiplied to V2 square will be equal to 4 root 2 square is equal to 16 times 2 divided by 2 is 16. Now this is right now in Pascal. If I make it in kilopascal, 1000 is gone, 100 minus 16, no calculator required, 84 kilopascal should be the answer. Again, if the answer is different, I'll assure you, question is also different. Next question. The next question over here is a question based on continuity equation. The question says, consider a unidirectional flow with a velocity flow field given by u is equal to x comma t function. It's a one-dimensional flow, let us say, u being a function of both x and t over here. The equation is given as 1 plus 0.2 e power minus t. The value of u at 2, 1 is equal to how much? If the value of u at, I believe this value was equal to 1. If the velocity u, let me write over here, if the value of u at 0, 1 is equal to 1, the value of u at 2, 1 is equal to how much? This is the question asked. Now, what is the continuity equation? The flow will be given by dou rho by dou t plus dou by dou x of rho u equal to 0. Now, since density over here happens to be a function only of density, only of time, I can write this as dou rho by dou t plus This can be written as rho into dou u by dou x must be equal to 0, which implies the value of dou u by dou x has to be equal to how much? It has to be equal to 1 by rho into minus of dou rho by dou t. Okay, keep this in mind. Let me take this in the next slide. So the value of dou u by dou x is equal to 1 by rho into minus of dou rho by dou t. Now, what is the value of rho over here? Rho is equal to 1 plus 0.2 e power minus t. If you differentiate this with respect to time, you are going to get minus of 0.2 e power minus t. Minus of 0.2 e power minus t. So let me write over here, dou u by dou x is equal to 1 by 1 plus 0.2 e power minus t times, 1 minute, yeah, minus of minus will be equal to plus. So this is going to be 0.2 e power minus t. That means if I integrate this, the value of u will come out to be equal to, the value of u will come out to be equal to 0.2 e power minus t divided by 1 plus 0.2 e power minus t times x plus, now please be careful over here, when you integrate a partial derivative, many people do a mistake of writing c. It is not c, it's a function of anything apart from x. Let us say over here time, because u is defined as a function of x and t, therefore a function of time will come. Now the question is, how do I find out this function of time? I don't even want the value of function of time, rather I want to know the value of function of time at time t equal to 1, because the asked question is also talking about t equal to 1. So for that I can use this condition. When x is equal to 0 and t is equal to 1, at x is equal to 0, t is equal to 1, the value of u is equal to how much? The value of u is equal to 1. The value of u is equal to 1. That means the function of time at t equal to 1 is also equal to 1. Now the equation of u eventually comes out to be equal to how much? U is equal to 0.2 e power minus t divided by 1 plus 0.2 e power minus t times x plus 1. This is the value of u at time t equal to 1. At time t equal to 1. Now you put in the value of time t equal to 1, x is equal to 2. I believe the value of u should come out to be nearly 1.13 units. The value of u should come out to be 1.13 units. Now this is a question coming from continuity equation. Continuity equation has always been the most important topic in entire kinematics. It will appear in your gate examination in one form or the other form. Apart from this, there was a question asked. I could not frame it though, but the question, I think the spirit of the question was, in a laminar boundary layer, if at a particular section you are having the value of delta equal to, let us say, at a particular section x, the value of shear stress is equal to tau. At a distance of 2x, what would the value of shear stress be equal to? Now this question is not new to you. As a matter of fact, this is a question from our material as well and previous gate examination. I can even tell you the question number in the material. It's question number 4 in the material actually. The value of this shear stress is equal to how much? Now you recall, tau is inversely proportional to root over of x. Therefore, this value of shear stress has to be equal to tau by root 2. As you move further along a plate, the value of shear stress has to keep on decreasing. So these are the questions which we have got from the students in the subject of fluid mechanics. I wish you were able to solve. Thank you, all the best.
Let's see the questions which came from machine design. So here we have got few questions. Let's see what are these. So here we have a question from brakes. So here it says like this. So a differential band brake is used for braking. A load P is applied at this location over the operating lever. And he's asking us to identify what is the ratio of tensions. If you observe carefully, he has given, so what is the angle of wrap and coefficient of friction? We know that the equation for ratio of tensions is, what is the equation? So we know that it is T1 by T2 is equal to e power mu theta. So T1 by T2 is equal to e power mu theta, where mu is given as 0.3 and the value of theta is given as 270 degrees, where when you convert 270 into radians, you get that as 3 pi by 2. So this is e power 0.3 into 3 pi by 2. So if you calculate this, you'll get the answer in around 4.11. So this is a simple question which we have got from band brakes. Okay. So moving to the next question. The next question that we have is from SN diagram, that is from second chapter. Very easy question. If you observe carefully from this diagram, he's asking us to identify what is the endurance limit. So here if you observe, so we have graph between log n and log s base 10. Now here if you observe, so y-axis representing amplitude stress, whereas x-axis representing the number of cycles to failure. And here you know that among these 4 points, P1, P2, P3 and P4, so P1 is representing ultimate strength and P2 is representing 90% of ultimate strength. See here, this diagram is valid for which material? He has given that the material is mild steel. And here we know that for at this location of P2, we are estimating that experimental this value is almost around 90% of SUT, and here P4 point is nothing but this is 50% of SUT. And we call P4 point, this point, if you observe carefully, this is nothing but the endurance limit point. So here, among these 4 points, see P3 is fatigue strength. Here, the right option, the right answer for this question is P4. Okay. Moving to the next question, he's asking us to identify the principal stress at a point in a metal is given as, so in a component it is given as 70 megapascal and minus 70 megapascal. So here, he's asking us to identify, okay, the yield strength is given as 100 megapascal. So which of the following predictions is true? This is what is asked. So here, if you see the first prediction, maximum normal stress theory predicts that material does not fail. See, we need to know, so what is the condition according to maximum principal stress theory and what is the condition according to maximum shear stress theory. We know that the condition according to maximum principal stress theory is sigma max lesser than or equal to SYT. So here what is maximum? 70 is maximum, and you can see that minus 70 is minimum. This is max and this is minimum. Okay, see right extreme and left extreme. So here if you observe carefully, is this giving us a right condition? 70 lesser than or equal to 100. Is this the right condition? Yes, this condition is right, which means according to maximum normal stress theory, the system or the component is still safe. If I consider maximum shear stress theory, which is nothing but sigma max, the condition, this is the final condition that we get. So sigma max minus sigma minimum lesser than or equal to SYT. If you observe carefully, so if this value is lesser than SYT, the system is safe. Okay, this is a safe condition, right? If I consider this value, this is 70 minus of minus 70 lesser than or equal to 100, which means 140 lesser than or equal to 100. See here, it says that the component is failed according to maximum shear stress. Why? Because, so this is a safe condition. This safe condition is invalid here. This value of maximum minus minimum has to be lesser than SYT for safety. But here it is not lesser, it is greater than SYT value, which means according to maximum shear stress here it is failed, and according to maximum principal stress here it is still safe. So what is the answer here? Maximum normal stress theory predicts that the material does not fail. Yes, this is right answer. Normal stress theory, that is, okay, here shear stress theory predicts that material does not fail. According to shear stress theory, the material is failing. So these two are the right options for this question. So we have got very simple questions from machine design. So I hope you might have tackled these questions very easily. So I'll transfer to the next faculty.
back, students. I'm Dr. Manikumar. I'm here to discuss memory-based questions on mathematics. Okay, some topics of mathematics, that is, actually we have got an information this time. 9 questions were given on mathematics. Right now we have 7 questions are available. Okay, I will give you solutions of memory-based questions on complex variables and on numerical methods. Actually, one question given on complex variables. This is f of z. F of z is nothing but e power minus kx into cos 2y minus I sin 2y is analytic. Then what is the value of k? Then k is equal to what? Okay. Now, using CR equations, you can find the value of k. That is one process. But okay, without using CR equations also you can do. You can save your time. You see this question once. Okay, what is f of z here? F of z is nothing but e power minus kx into cos 2y minus I sin 2y. You can write it as e power minus 2iy. Already you know that. So you see, already this function is an exponential function. Exponential function is analytic everywhere, you know. So if I take k is equal to 2, using CR equations you can solve this problem. But if you take k is equal to, this is nothing but e power minus 2x into e power minus 2iy. Take minus 2 common, that is, if I e power minus 2x e power minus 2x minus 2iy, that is e power minus 2 into x plus iy, that is e power minus 2z. Is it? So this is analytic everywhere. So in place of k, see, this is nothing but in place of k, what is there here? 2. So clearly e power minus 2z is analytic function in place of k. 2 satisfies, so k is equal to is an answer. Are you clear? Now coming to the next question, one more question they have given on numerical methods, that is, given differential equation, one differential equation dy by dx plus 2y is equal to 0 with initial condition y of 0 is equal to 1. Here the question is, this is initial value problem. Yes, using forward Euler's method, what is the maximum step size? Means what is the maximum tolerable h? We have to find the maximum value of step size h. Okay, using already, without making unstable solution, what is the maximum step size? Okay, so solution should be a stable solution. To give a stable solution, what is the maximum step size? You have to find. For that, okay, now the differential equation you can write like this. Dy by dx is equal to minus 2y. So already you know dy by dx is equal to f of xy with initial condition y of x naught is equal to y naught. If you apply forward Euler's method to give stable solution, what is the condition? 1 plus h into dou f by dou y is less than 1. So here, what is f of xy here? Here f of xy is nothing but minus 2y. What is dou f by dou y? Minus 2. Now, apply that condition. What is the stability condition? Okay, so 1 plus h into dou f by dou y is less than 1. Without making unstable solution, to find the maximum value of h, you have to use this condition. That implies 1 plus h. What is 1 plus h into, what is dou f by dou y? Dou f by dou y is minus 2, less than 1. So, 1 modulus of 1 minus 2h is less than 1. Next step. Modulus of 1 minus 2h is less than 1. It is looking like mod x less than 1. Already you know, if mod x is less than 1, minus 1 less than x less than 1, like this. So, this you can write it as minus 1 less than 1 minus 2h is less than 1. Now, I have to find h value so that, so try to remove this one. For that, take minus 1 on every side. So, it will become minus 2 less than minus 2, h less than 0. That is nothing but 0 less than 2h less than 2. That implies 2h less than 2. That implies h is less than 1. So what is the maximum step size without making unstable solution? H is 1. So up to 1 gap it is a tolerable gap. If you exceed that one, that is not tolerable. Okay, these are the two questions, one on complex variables and the second one in numerical maths. Next 3 questions will discuss our senior faculty. Venkatrao sir will discuss the questions on probability and differential equations.
Hi, myself P. Venkatrao. I'll be discussing probability statistics along with the differential equations and Laplace transforms. So we were given one question from probability and statistics from Poisson distribution, which is the most expected topic, and every year almost we are giving the question from Poisson distribution both for mechanical and civil. The question: a machine produces a defective component with a probability 0.015. The number of defective components in a packed in a box of 200. That means a number of defective components. The number of components in that box should be 200. And we were just asked to find. Actually, we were asked to solve this problem using Poisson distribution. Even though they don't mention to solve this problem using Poisson distribution, still you can solve that problem using Poisson distribution as number of trials are very large, that is n greater than or equal to, its n is 200, which is large number of trials, and probability is very small. Therefore, it is related to Poisson distribution. We were simply asked mean and variance. As we all know that mean and variance of Poisson distribution are same. And mean of the Poisson distribution is simply lambda equal to. So lambda is the representation of mean. If you want, you can also denote it by mu as well. So mean mu equal to NP, that is 200 into 0.015. Therefore, lambda equal to 3. Mean of the Poisson distribution is lambda. But we know that variance of the Poisson distribution is also lambda. Therefore, mean and variance are 3, 3 respectively. We were given the options mean and variance as option A 3, 3, option B 1, 1, something like that. We were given the options. Option C root 3, root 3, like that. So the next question: what is the inverse Laplace transform of 1 by s cube minus s? What would be the inverse Laplace transform of 1 by s cube minus s? Do you know? Here s is the common factor, so that we can take out s common. If we take out s common, then it becomes s into s square minus 1. And moreover, s square minus 1 should also be written as s into s plus 1 into s minus 1. So we just have to split the given function into partial fractions. So partial fractions are a by s, b by s plus 1 plus c by s minus 1. We have in the left side 1 by s cube minus s. And observe this, you can simplify and then solve. Directly you will get the values of ABC like this. I mean, just you need to take the LCM and compare the numerators. you will get the values of A, B, C are A value -1, B value 1/2, and C value 1/2. These are the values of ABC. But in the exam, you will have to find ABC values just by comparing the left side and right sides of the numerator. Simply substitute ABC values and apply inverse Laplace transforms, you will get the required answer. Here, 1 by S Q minus S, that is equal to, what is A value? -1. -1 by S plus what is B value? 1/2. 1/2 into 1 by S plus 1. What is C value? That is also, I think, 1/2. 1/2 into S minus 1. Apply inverse Laplace transforms both sides. Then it becomes inverse Laplace transform of 1 by SQ minus S equal to inverse Laplace transform of 1 by S minus 1 by S plus 1/2 into 1 by S plus 1 plus 1/2 into 1 by S minus 1. So this is L inverse of K by S. L inverse of K by S is K. K means -1. -1 into U of T, where U of T is unit step function. The value of unit step function should be 1. I mean U of T value 1 for the region T greater than 0. And plus 1/2 into L inverse of inverse Laplace transform of 1 by S plus A. Inverse Laplace transform of 1 by S plus A, that is e power minus AT, whereas A value should be 1, plus 1/2 into inverse Laplace transform of 1 by S minus A. So A value 1. So e power AT, L inverse of 1 by S minus A value. For each case we can write in each case we can write U of T, where U of T is 1. Plus 1/2 into U of T. So 1/2 into e power T into U of T. So U of T is the common factor. So therefore -1 plus 1/2 into e power T plus 1/2 into e power T into U of T. This is the required inverse Laplace transform for the given function 1 by SQ minus S. And the one more question regarding differential equations, and it was given for 2 marks. And every year we are expecting from last 3-4 years frequently that model they are covering in the GATE, Cauchy-Euler's method, that is x square d square y by dx square. Let me write the question. X square d square y by dx square plus x dy by dx minus y equal to 0. Not only this differential equation, along with that we need to solve the general solution with the help of some of the conditions given. Once we get the general solution, we need to apply those conditions. And moreover, what you need to remember is, this problem is related to Cauchy-Euler equation, and I hope you all people know that the assumptions made regarding Cauchy-Euler is ln x equal to t. I hope you are able to remember all this. Ln x equal to either t or z, and moreover x into dy by dx should be written as capital D into d minus x into dy by dx is capital D into y, where capital D is d by dt. If you assume ln x equal to t, actually some assumptions are there, because Cauchy-Euler equation cannot be solved directly. It can be reduced to linear differential equation, which we have already discussed in regarding linear differential equations. So you may assume ln x equal to t or z. If you assume ln x equal to t, then capital D stands for d by dt. Otherwise, if you assume ln x equal to z, capital D stands for d by dz. What are the assumptions? X square into d square y by dx square will be written as a d into d minus 1 into y, plus x into dy by dx is written as capital D into y minus y equal to 0. Moreover, this is a homogeneous differential equation, so we need to find only complementary function. That itself is the general solution. So here a d into d, d square. Here a d into minus 1, minus d into y, minus dy plus dy cancel. Simply d square y minus y, whereas y common, it should be written as a d square minus 1 into y equal to 0. So what is the auxiliary equation? D square minus 1 equal to 0. What are the roots of the equation? D equal to 1 comma minus 1. So d plus 1 into d minus 1 equal to 0. So complementary function. Since it is a homogeneous differential equation, complementary function will only be the general solution. So general solution should be written as y equal to c1 e power t, because roots are real and distinct, plus c2 e power minus 1 into t. But what are the assumptions? ln x equal to t, so that x equal to e power t, so that 1 by x equal to e power minus t. Therefore it becomes y equal to c1x plus c2 by x, e power minus t is x, 1 by x. What are the conditions given? In the exam, along with that, we were given two conditions, y of 1 equal to 6 and y dash of 1 equal to 2. Y of 1 equal to 6. Y of 1 equal to 6 means what is y value when x equal to, what y value 6 when x equal to 1. In equation number 1, substitute y value 6, x value 1. So C1 plus C2, that's it. Let it be equation number 2. From this we did not get the values of C1 and C2. That's why we were given another condition. If you wish to apply this another condition, you have to find y dash. What is y dash? Y dash equal to C1 into x, that is C1, C2 by x, C2 by x, that is minus C2 by x square. Let it be equation number 3. What is that another condition? Y dash of 1 equal to 2. Y dash of 1 equal to 2. Therefore equation number 3 implies that its meaning y dash value 2 when x value 1. Y dash value 2 when x value 1. Then it is C1 minus C2. Let it be equation number 4. Observe equations 2 and 4. Equation 2, C1 plus C2 equal to 6. Here C1 minus C2 equal to 2. By solving 1 and 2, you will get the values of C1 and C2. From 1 and 2, we get, just imagine, if you add equations 2 and 4, here C1 plus C2, here C1 minus C2, 2C1 equal to 8. So 2C1 equal to 8, so that C1 equal to 4. If I take C1 equal to 4 here, then C2 equal to 6 minus 4, that is 2. C2 equal to 6 minus 4, that is 2. Once we get the values of C1 and C2, substitute here, 4x plus 2 by x, 4x plus 2 by x. Therefore the complete solution is y equal to 4x plus 2 by x. Actually this is the general solution. This is the complete solution but not the general solution, but actually we were asked to find the value of y when x equal to 2. I mean the value of y of 2 is dash. It is a numerical answer type question. Y of 2 means y value when x equal to 2, that is a 4 into 2 plus 2 by 2, that is 1. Answer, this is 9. So we have few more questions from calculus that will be teaching by concern or my colleague V. Aditya Srinivas will take over the session. Thank you.
Now let's look at the questions related to calculus. They gave some region like this, x square plus y square less than or equal to 1. So this is something like this. This is the region. They have used some transformation like x cap equal to 3x, y cap equal to 2y. Now what is x from this? It is x cap by 3. What is y from this? It is y cap by 2. Now substitute this and see what kind of curve is this or what kind of region is this. When I substitute, I get x cap by square, so it's 3 square like this, and here also there is a square, then y cap square by 2 square less than or equal to 1. Now this is going to represent ellipse like this. Okay, they're asking what is area of this ellipse. Now we know that this is like x square by a square plus y square by b square. Area of the ellipse is pi ab. A is 3, b is 2, so pi ab is 6 pi. So the answer for this question is 6 pi. The next question, it's about Gauss divergence theorem. They give a vector field like this, b bar, which is xi plus yj minus 2zk, and they give a closed surface that is cone. They're asking you the surface integral. Now once I observe that surface, I conclude that it's a closed surface. I can use Gauss divergence theorem. According to Gauss divergence theorem, the closed surface integral, that is b bar dot n bar ds, is triple integral divergence of b bar dv. Now the divergence of b bar turns out to be 0, that is 1, the partial derivative of this is 1 plus 1 minus 2, so it is 0. Now when the divergence is 0, when you put 0 here, the entire answer turns out to be 0. These are the questions from engineering mathematics. Next, Devanand sir is going to take the session.
Hello everyone, I am Devanand, faculty of Heat Transfer in AC Engineering Academy. So today's session in Gate Mechanical, total 5 questions are asked. So let us cover. Consider incompressible laminar flow of a constant property. So please make sure there is a constant property. So if you take care of this, this is constant property. Newtonian fluid in which isothermal circular tube, the flow is steady with a fully developed temperature and velocity profile. The Nusselt number for this flow is dependent on. As you know, in case of laminar fully developed flow, Nusselt number is constant, that is 3.66. So Nusselt number is not a function of Reynolds number and Prandtl number. So answer is neither Reynolds number nor Prandtl number. Simple one. Next one. Consider a laterally insulated rod of length L and constant K. Assume one-dimensional heat conduction in the rod. Which of the following steady-state temperature profile can occur without heat generation? Make sure this graph is a straight line. So there is a rod and this rod is insulated. So we need to find out what is the temperature profile. If there is no heat generation, the profile is linear. So if it is a MSQ question, then you have to go for linear A as well as D, because without heat generation there is only linear. So 2 curves are there. This is straight line. This is also straight line. So A and D should be the answer. Next. Consider a counterflow heat exchanger with an inlet temperature fluid T1 and T2. So let us write lowest one TC1, that is 300, and TC2 is 350. So the heat capacity ratio of the two fluids C1 1000 and 400. So minimum you have to check. So what is minimum? C minimum, that is 400 watt per Kelvin. and the effectiveness of the heat exchanger is 0.5. So actual heat transfer, so effectiveness is equal to Q actual by Q max. So if you solve this, Q actual, that is effectiveness into C mean, TH1 minus TC1, you will get answer 10,000 watt. But we need to express in kilowatt, so answer should be 10. So very simple question from heat exchanger, answer is 10. Next, a very large metal plate of thickness D, it's a metal plate, so D is the thickness, thermal conductivity K, cooled by a stream of air at a temperature T infinity is equal to 300 with a heat transfer coefficient K, shown in the figure. The center line temperature of the plate is Tp. Which of the following cases can be lump model be used? So lump model is used when the Biot number is less than, so HLC by K, it should be less than 0.1 and it's a plate. So you have to take D by 2, K, it should be less than 0.1. So you check, this is the MSQ question. So if you check, B and C will cut out. So 1 mm, 1 mm, if you solve, I think you will get A and D answer. Make sure this is the memory based question. So option may be here and there, but the funda is same. You have to check Biot number is less than 0.1. So 2 options you will get. Next one, a cylinder of diameter D and height H is placed inside the cuboid of L, side L. What is the view factor F if S denote the inner surface cuboid? So in this question, FSS asks, this is the memory based question. So there is a cuboid, in that cuboid there is a cylinder. So let us write cylinder is 1 or this is 2. So in the question he asks F22. So as you can see, F11 0, F12 1. So if you apply reciprocity, A1 F12 is equal to A2 F21. So F21 is equal to A1 by A2 into 1, and then F21 plus F22 is equal to 1. So 1 F22 is equal to 1 minus F21. So just substitute the areas, 1 minus A1 by A2. Just substitute. What is the cylinder area? Pi by 4 d square plus pi dl plus pi by 4 d square. And cuboid area is 6 into side square. That's it. So if you do that, you will get this answer, 1 minus pi by 2 d square plus pi dh upon 6 L square. So this is the common shape factor question. So that's it from my side. Now my colleague will take care of it.
So dear student, coming to IM and OR. So you can find two questions in IM and OR. So we had data from students. So maximize Z is equal to 45x1 plus 60x2 subjected to x1 less than or equal to 45, x2 less than or equal to 50. So this constraint, it could be 25x1 plus 5x2 less than or equal to 750. Fourth constraint 10x1 plus 10x2 greater than or equal to 600. So it was given like this, of course, simplified. And we are supposed to find out Z max value. So Z max, how much? So if you solve this problem, so you will get Z max is equal to 3900. So it is just graphical method. So we can use graph. Then for the sake of graph, there are 4 constraints. So just how do we get the graph? Just I am preparing like this. So 10, 20, 30, 40, 50, 60. On this 10, 20, 30, 40, 50, 60, 100, 150. Just I am marking like this. This is an x2. This one is x1. So coming to first constraint. So what is the first constraint? x1 less than or equal to 45. x1 less than or equal to 45. So a vertical line you will get. Less than symbol is no. So 0, 0 if you substitute, satisfied. So hence shade area towards origin. So this side you will get. And coming to second constraint, x2 less than or equal to 50. x2 less than or equal to 50, it is passing through 0, 50. 0, 50, and this one is 45, 0, and towards origin. So towards origin you will get. And come into another constraint, 25x1 plus 5x2 less than or equal to 750. So this is passing through 0, 150. I'm using another color. 30, 0, 0, 150. And this is less than, so we can shade towards origin. I'm just taking the region this side. So this is a common region so far. And coming to next constraint, 10x1 plus 10x2 less than or equal to 600. It is passing through 60, 0, 0, 60, 60, 0, 60, 0, 0, 60, this point. And if you join this, so it is get like this, and away from origin. So what is a common region for all 4 constraints? This is a common region. So this common region contains 3 corner points. So this corner point, so easily you can identify. So 50 if you substitute in this constraint, so you will get this as 10, 50. So this point is say A. A point is 10, 50. This is point B. So if you solve these 2, then you will get it is around 20, 50. And this is point C. It is 22.5, 37.5. So you can no need to take A. Now the answer could be either B or C. If you substitute 20, 50, because the given objective function is 60 times of x2. So it is just like a common sense. Directly we can take option B. This is actually optimal solution. So unique optimal solution, if you substitute 20, 50 in Z. So Z is equal to 45 times of x1 plus 60 times of x2. Z at 20, 50 is equal to 3900. So answer is 3900. So you will get actually 3450, 3900, 3262. So answer is highest value, Z max is equal to 3900. So this is regarding graphical method. So coming to next question. Actually, there are three cost elements, cost versus quantity mentioned. Suppose if it is inventory control, this horizontal line you won't get. So this graph is actually related to economics in machining. So in case of machining, so this R is going to be setup cost. And instead of quantity, if it is economics, engineering like economics in machining, this is going to be cost. This is actually speed. So we got data from student. They're not sure about exact data. They could not able to recall. Suppose if I take cost versus speed, this line is actually setup cost. Setup cost is constant. And next, coming to tool cost. The tool cost is going to be like this. And another one, like we know production cost. Production cost or machining cost. Machining cost is going to be in this way. The machining cost is like inversely proportional type. And total cost is going to be like, these are total cost. This is always total cost. This one is tool cost. And this is actually production cost or machining cost. Production cost. And this horizontal line is setup cost. If it is economic order quantity, suppose this is no doubt, it is a total cost. This is actually carrying cost or holding cost. If it is inventory control means, this AC is nothing but ordering cost or procurement cost. But straight line you won't get in case of EOQ model. EOQ model does not use this kind of horizontal lines. It is production model, even it could be production model also, you won't get any line. So it is no way concerned to inventory control. I don't think so it is inventory control. It is only machining related question. So that's all about industrial management.
Hello everyone, myself Hazrat. I'm the faculty for Strength of Material. From SOM this year almost 8 questions came guys. Now we will see one by one. Now coming to the first question, you please go through the question guys. I'll just simply explain. There are two bars are there P and Q which are fixed between two supports and which are heated. Then what are the corresponding options? What happens between the two bars? This is a question they're asking guys. The first thing is, whenever they are heating, this will give you support reaction. Because of support reaction, the stress here is how much guys? R by A. Here also how much? R by A. Stress is same. So this option is correct. So this is a multiple select question, my dear students. First option is correct. So second option is definitely wrong. Then third one is the trickiest one guys. Intermediate point will shift towards right or towards left. For this, you need to know the deflection guys. How can you find out the deflection here? Very simple. Deflection in this P bar equal to how much? Due to heating, L alpha T minus due to support reaction, RL by AE. Yes or no? This is P. If this is coming positive means this is moving towards this side. This is coming negative means this is moving towards left side, guys. Similarly, deflection in the Q is same as L alpha T minus RL by AE of Q, guys. But here observe, my dear students, here he has clearly mentioned that E, this E value is, please observe carefully, sir, the E value is, iska E value is less. Sorry, iska E value is more they have given. As iska E value is more, this value will be coming positive. This value is coming positive means this is elongating. Elongating means this is moving towards left side. So correct option is what exactly? Option D. Now coming to next question, guys, straightforward question. There's a cantilever beam subjected to point load. What the stiffness equal to how much? You know, pretty straightforward for question. Deflection equal to how much? WL cube by 3EI. Then stiffness equal to how much? Force per deflection? 3EI by L cube. Option B is the correct answer. Third one. There's a question on the shaft. Please go through the content. What they're asking is, guys, what is the power transmitted by the shaft? Direct formula based question, my dear students. That is 2 pi nt by 60. He has given the n value. Unknown is t. For finding t, he has given the clue that the shaft is twisting 0.5 degrees when it is running at n RPM. How can I find out this one? Direct formula, guys. You know this formula. G theta by L equal to T by J. From this T I can get, substitute the T here, you will get the corresponding answer, my dear students. Okay? Now, coming to this question, guys, a pretty straightforward question. This question already given in the GATE 2011 or 12, they have given this question, guys. Please go through it. There is a tank which is filled with the water. Then he's asking, what is the variation of the stress? This is the question they're asking, guys. I clearly mentioned in the class that here longitudinal stress is same. Here longitudinal stress is mentioned with sigma 1. So answer must be either C or either D, guys. But hoop stress will be varying, sir. Here also it is varying, here it is constant. But where it is same, exactly at the midpoint. Why it is at the midpoint, I clearly mentioned, guys. Answer will be gamma HD by 4T at this location. So answer is option C is the correct answer. Now coming to next one, guys. Yes. What is the Morse circle for this plane stress condition? I clearly mentioned in the class that, please observe carefully, the center of the Morse circle will be always in the x-axis. Now please tell me, guys, out of the 4 options, which circle having a center on the x-axis? Directly straightforward, option C and option D. Now coming to the next question, my dear students, he's asking self-weight bar. What is the strain energy stored due to self-weight bar? Here very directly, guys, you know the direct formula. Deflection, sorry guys, strain energy, right? Strain energy. What is strain energy formula? U equal to integral of 0 to L by Px whole square by 2EA into dx. Substitute Px. What is the value of Px, my dear students? Px equal how much? Take any strip here. What is the force acting on this strip? Assume length is dx at this location. What is the force acting? This is xi though. Assume area equal to A. What is the force, guys? Px equal to gamma Ax, guys. Substitute here. Integral of 0 to L gamma Ax whole square by 2EI into dx. If we just integrate this one, you will get the correct answer, my dear students. But don't worry, we'll provide the detailed solution once the real paper is out, guys. I just given how to solve this question. Next. So pretty simple question, guys. You can just simple formula substitution as given that what is the moment of inertia about this axis? What you can do is, listen carefully, you can split this one into one rectangle ball. Yes or no? I can convert like this. One rectangle bar. And you can join these 2 small triangles, guys. You can join these 2 small triangles. Then he's asking, what is the inertia about this axis? Inertia about this axis, guys. You know inertia about the center, you know, guys, how much? HB cube by 12. Yes or no? About this axis, how much? Assume this is the B. This is the HI though. BH cube by 12, guys, exactly. About this, how much I'm going to get? BH cube by 3. Now, you know about this axis, I know that BH cube by 36. But I want about this axis, guys. Using parallax theorem, I can able to find out. You will get BH square by 4. Just add. Simple formula substitution, guys. But this question given for 2 marks or 1 mark, please, you go through it, guys. With this, the SYM questions are over, my dear students. Hope you are done well. I wish you all the best, guys. Thank you.
Very good evening to all of you. My name is Mohammad Waidullah and I'm faculty of Tom at ACE Engineering Academy. So guys, this year we have seen 3 questions from the subject theory of machines. And first question is from the chapter gear and gear trains. So 2 gears having a center distance of 30 mm. Center distance is given R in mesh as shown in the figure. If the speed ratio is 4, the diametrical pitch is 8. Then the number of teeth on the gear 1 is equal to dash. Guys, here the center distance is directly given to us. So center distance, that is equal to radius of 1 plus radius of 2, okay, which is equal to 30 mm. And here we can see the speed ratio is given. Speed ratio I can write here, that is omega of 1 by omega of 2 is equal to 4. Or I can express this in terms of radius also. Radius of 2 divided by radius of 1 is equal to 4. Okay. So here we can write it as that is radius of 2. We can write this as R1 plus 4 times of R1, which is equal to 30. So R1 is equal to, that is 30 by 5, which is equal to 6, guys, which is equal to 6. Now here the module, instead of module they have given the diametrical pitch. Diametrical pitch, that is PD, is equal to inverse of module. So module here I can say that module is equal to 8 mm. So number of teeth on, that is T1 is equal to, that is 6 into module is 8, that is that is 48. Sorry, here 48 it is. Okay, so option C is the answer. Next question, guys, the ratio of omega 1 to omega 2. This is a question from the mechanisms chapter. So here we can solve this question by the eye-center method. First is that you can recall the fundamentals from the concept rolling motion. So velocity, this is omega 1. So velocity at the center of mass will be equal to, that is radius is given as 3 meters and this is omega 1. So velocity at the center of mass will be equal to 3 times of omega 1. Okay. And moving to this point, at this point we will have the velocity in horizontal direction as
3 times of omega 1, okay, and similarly velocity in the vertical direction will be given by the radial distance from the center of mass, okay, which is equal to 2 meters, and this will be 2 times of omega 1, guys. This will be 2 times of omega 1. So the resultant velocity of these two will be, that is, this is 9 square, 9 plus 4 is 13, so this will be root 13 times of omega 1, guys. Root 13 times of omega 1. So now, guys, if we join the vectors, that is, this will be the velocity, and this point is going to slide in the horizontal direction. So let us name this point as B, or velocity of B, and let us name this point as velocity of A. Now, guys, here this is 8 meters, and so from this, this will be also 8 meters, and this will be 3 meters, guys. Okay, so this is omega. Omega is in clockwise sense. So, okay, sorry, I have made a mistake here. This 2 omega should be downwards, guys. This 2 omega 1 should be downwards like this. This will be 2 omega 1, and the resultant velocity direction will be modified. It will be like this, guys. This will be root 13 times of omega 1. Okay. So now, guys, this will be the, if I join the vector, if I join from the point of contact up till this point, so this will be perpendicular, guys. This will be perpendicular. Okay, this will be perpendicular. Now, guys, here this point B is undergoing rectilinear motion. So its eye center will be lying somewhere on the vertical line, okay, and this is another line. If we intersect, or if we extend these two lines, they will meet at this point, which we call it as the eye center, okay. Now, guys, this rod will be undergoing general plane motion. This rod will be undergoing general plane motion. So we can write here velocity, this is 13 and this is 8. So, guys, this angle and this angle will be same, So if this is 2 meters and this is 8 and this is 3, so this can be 12, guys, if we take the slope. Okay, so we can write here that is 2 by 3, this is 2 by 3, or if we take the angle that is tan inverse of 2 tan theta, or if we take this as theta, so this will be 2 by 3 is equal to, and this angle would be, the adjacent side would be 8, and the height would be something h, let us write. So this will be h is equal to, that is 8 into 3 by 2, which is equal to 12, guys. This will be 12. Now, guys, we can apply here velocity theorem. That is, let us write this as velocity of A. Okay, so velocity of A divided by, this is say point I, and this will be IA, is equal to velocity of B by IB. Okay, so velocity of A, we have written that as root 13 times of omega 1, and that is IA. IA, guys, is this length, okay? IA is this length. So, yes, here will be the velocity, guys. This will be the velocity. This will be the velocity. This will be the velocity. Okay, for this velocity, we can write that is let us say this is point A, and let us say this is point C. So velocity of C is equal to, this radial distance. This radial distance is root 13 into omega 2 is equal to, and this distance will be root over 12 square plus 8 square, that is equal to 208, which is equal to 208, root over 208 into omega 3, guys. So here they are asking, okay, so they are asking us to calculate omega 2, that is velocity of rod. Okay, velocity of rod will be omega 3. Okay, velocity of rod is omega 3 divided by omega 2, which is equal to, that is root 13 by root 208, which is equal to 1 by 4 guys, which is equal to 0.25, which is equal to 0.25. So option C is the answer. Okay. Moving to the next question. Yes, this is a straightforward question from the vibrations chapter. So here natural frequency, that is omega n, is equal to root over k equivalent divided by m. So k equivalent, here it is two springs are connected in parallel combination. So 2k by m, and we can write this as omega n is equal to root over 2 times of 100 divided by m is 20. M is 20. So upon solving this guys, we are going to get this as that is 20 by 2000, that is 100. So this will be 10 radians per second. So natural frequency or time period of the undamped vibration will be Tn is equal to omega n, or this will be, 2 pi by omega n. This will be 2 pi by omega n. So guys, this will be equal to 2 pi by omega n is 10. This is equal to pi by 5 seconds. So here they are asking us to calculate what is the time taken for the 5 cycles. So time for 5 cycles will be, you have to multiply this with 5. You have to multiply this with 5. So this will be equal to pi seconds guys. It will be equal to pi seconds. Just a minute. This is 2 into 1000, that is 2000 by 20. So this is equal to 20,000, 2000 by 20 is 100, 110 radians per second, and this will be 2 pi by, yeah, this will be pi seconds. So 3.14 will be the answer guys. So these are the questions from the theory of machines and vibrations.
Hello, my dear friends. Let us go ahead with numerical ability question solutions. See the first question. Here they given a set of numbers. Okay, 1, 2, 3, 4, 5, 6. Okay, is a set of numbers is given. Now here they are asking. See the question carefully. Okay, how many pairs of SNT are possible among the subset of 1, 2, 3, 4, 5, 6 that satisfies the condition S is a subset of T. See, first of all, okay, S and T we should take from 1, 2, 3, 4, 5, 6, S and T both, and S should be a subset of T, that's the condition, right? So instead of doing for the 6 numbers, 1, 2, 3, 4, 5, 6, which is bit time taken, I'll explain with only 2 numbers, 5 and 6, then that analysis can be mapped here. Let us take, okay, given numbers are only 5 and 6 for example, okay, S is a subset of T, so T may be null, okay, T is a empty set, T is a empty set, S is empty set, yes, S is a subset of T, one chance, right? Then if suppose T is 5, S may be a null, okay, or S can be 5. So here 2 chances, 2 possibilities satisfying the condition. Okay, next, T can be 6, T is having element 6, S can be a empty set or S can have 6. Here two possibilities, T 6 and pi, 6 and 6. Next one, T can be 5 comma 6. At that time, S has having a chance, it may be pi, okay, null, or it can be 5, or it can be 6, okay, or it can be 5 comma 6 as well, right? S is a subset of that, it can be 5 comma 6 as well, right? So we got 4. Now adding all this, my dear friends, we got 9. See the simple thing, when you have 5 and 6, only 2 elements, we got the answer as 9, which is actually 3 square. When you have 2 elements, we got 9. See the analogy now. When you have only 2 elements, 5 comma 6, we will get answer as 9, which is 3 square. When you try the same procedure like this for 3 elements, 4, 5, 6, if you try for 4, 5, 6, then you will get 3 cube, 27. But here they given 6 elements, we should do 3 power 6, which is 729. See, analyzing this big task, that's what we're given you during your sessions. When you have big numbers, work with the small numbers, understand the logic, apply for the big numbers. Don't try directly for the big numbers and don't waste your time in exam. Now see the second question. Here, the smallest perimeter that a rectangle with area of 4 square units. So 4, okay, the units may be meters or something. So 4 meters square, let's say, this is the area of a rectangle. But perimeter should be less, they're asking, right? See, when you will get the perimeter of rectangle smallest is, when this rectangle becomes square, means length and breadth both must be equal to A, then you will get, okay, with less perimeter, more area will be covered when length and breadth are equal. So from this, if length and breadth are equal, we will get A value 2. We know perimeter of, rectangle, square is one type of rectangle. Now this is a square shape where each side is nothing but equal to A. We know perimeter is 4A. So we got 4 into 2. 8 is the answer, my dear friends, here. 8 units. Each side is 2, 2 like that. We got 8. Rectangle becomes square, then only the smallest perimeter of rectangle, getting the area of 4 square units, will be obtained. Now see this question related to clocks. Okay, they given minute hand and second hand in regular for all competitive, other competitive exams. Hour hand and minute hand they are giving, but last year and this year both for mechanical itself, they given a question related to minute hand and second hand related. So how many times this minute hand and second hand cross each other between and? Guys, this is the question. Okay, we got database from the students. Here between and is there, answer will be different. From to is there, answer will be different. You have 29, 30, 31 also. Close options are there. Depends on whether it is between and or between from and to. Whether they given the question from 9:15 a.m. to 9:45 a.m. or between and, depends on that. We are assuming this question is given for between with the word between and. Okay, now again I am doing, don't go for entire 9:15 to 9:45 a.m. Do for 9:15 to 9:20 a.m. So 9:15 to 9:16 first of all. Say 1 minute, every minute hand and hour, second hand will overlap. They'll cross each other. Here one time, 9:15 to 9:16, one time. 9:16 to 9:17, one time it will overlap or cross each other. 9:17 to 9:18, 9:19 to 9:18 to 9:19, similarly up to 9:20. So here 9:15 to 9:20 itself, we got 5 times it is overlapped within that 9:15 to 9:20. You extend the same thing up to 9:45, you will get answer 30. Here options are very close enough. 29, 30 and 31 is there. Okay, we are taking the question considering between 9:15 a.m. and 9:45 a.m. Your answer will be 30. This I am giving only for 5 minutes. You can do that analysis for 9:45 a.m. up to that. Okay, every minute one time it will overlap. That's simple point. Now see this question, equation solving we have to do. Okay, they given 2 inequalities and need to perform the equation solving. A lot of people wasted their time in exam by solving these 2 complicated equations. Simple thing, they given a condition in the question, P and Q are positive integers. Okay, P cannot be 0, Q cannot be 0, positive they mention, right? So now we go for P value minimum 1, okay, Q value minimum 1, minimum. I'm speaking about minimum value of P and Q.
right? Okay, minimum value of P and Q. And see the condition, one condition will check. What you can do, take minimum value for P, Q, check is this condition satisfied or not. Or else take P value 1, Q value 2. Thing is like you can go with P value 1, Q value 1, P1, Q2 or P1, Q3 like that, because options maximum 4. P plus Q only 4 is given. As options are given, try to utilize it. Okay, this is one set. Then you can try Q value 1, P value 2 like that. You can increase. But see my dear friends, these conditions, what are the conditions they given? You just see P value 1, 3, Q value 1, 2, 3 plus 2, 5, 5 less than 6 is correct. Only for P value 1, Q value 1 only. So P plus Q is nothing but equal to 2. P plus Q is 2. So why not remaining? Why not remaining? You substitute P value 1, Q value 2 here. P value 1, Q value 2 will give 7. 7 less than 6 is wrong. So just be in a gentle manner, solve the question using the word positive integers. Don't take 1.5 those time waste things, okay? Some people say, sir, why not P2, Q1? You tried here, you substitute P2, Q1 also. It will not satisfy this equation. Only one equation I am checking. All failed except P value 1, Q value 1. Instead of solving this two inequalities, go with the option verification as maximum value 4 and P and Q are positive integers. Right, simple way of doing. Next question, data interpretation. We know every time they are asking this question from data interpretation. Here, one is they given university, okay, one is college, right? These universities are they given clearly, 504 universities is there. Colleges in particular city is 25,000 or particular country. A particular country, a certain country is having 504 universities and 25,951 colleges. Fine. Now question what they are asking as GATE exam, virtual calculator allowed, you people can do very simple. Grade 3 is what out of the total colleges and universities? Grade 3 is what percentage of total colleges and universities you should add these two. Simple thing, see, grade 3 here 7% of 504, calculator allowed 7% of 504. In that is universities, grade 3 universities. Here grade 3 colleges are 23% of 25,951. Total is 504 plus 25,951 into 100. Very simple question. This is data interpretation. Grade 3 out of total. Actually they are asking you do this calculation as calculator allowed. You have option approximately will get 22.7. 22.7, 22.67 like that. But among options, they asked you people actually, here they mentioned up to 1 decimal you have to round off. Okay, you can take 22.7 as the answer. Now this question, GATE 2015-17 time also they given, one graph is given in the question and you need to find f of x function related to that. Okay, so guys, as you are from mechanical branch, okay, this type of graphs you people get very rarely, whereas in electronic students, they'll get this graph, they'll do the signals and systems and all there. But for you, what is the best method is, take one point and do option verification. I'll take C, for x value minus 4, your answer must be 2. This f of x function is giving 2 for x value minus 4. Simple substitute, which among the options is generating for x value minus 4, f of x is 2, which option is generating? You see, suppose x value minus 4. If you put x value minus 4 here, okay, it will minus modulus is that it will become plus. So 2 minus 4 will give minus 2. It is not the scenario. Then if you substitute here x value minus 4, I think this will give plus 2. This will results to plus 2. Wait. And what about B is not having modulus. 2 minus of minus 4 will give 6. This is giving 6, not acceptable. Whereas next one also giving 6 for you. This is also not acceptable. Only option A. I'm not going for, you can do the question like taking the slope points, okay, forming the straight line. You can do a lot of things, but simple idea, you take certain point, minus 3. You take other point also. For x value minus 3, your f of x must be equal to 1. You do option verification, which function is satisfying that. Simple way of doing is this, dear. And this is pseudocode, okay, very easy actually they given, okay. Here they given a condition, they given 4 symbols.
My 4 symbols is there. These are the 4 symbols: triangle, multiplication, square, and circle. We know in pseudocode, row should be filled with 4 different symbols, column should be filled with 4 different symbols, and there is one more advantage for you. They given this part is having only 4 different symbols. Every square which is colored in different, it should be bold line in exam. Here for understanding I given different colors. In exam they bold this. This 4 also must be different. In this 4 set of things should be different. Here 4 should be different. First thing, if you observe this column, okay, here already square is the triangle, star, this should be filled with circle. Okay, this should be filled with circle. Now, this star point cannot come, star point cannot come. Question mark must be simply star. It's a very easy question, straightforward question. What should be filled here is star. Because this row, star is already there, star is already there. So I can get star only in this place. One symbol, it entire column or entire row wise or column wise you observe, only one time it's possible. That's only here, dear. Okay, you have many clues actually. You see this column, star cannot be placed here, star must be here. This entire row, 4 different symbols required. 2 already there. Third one must be here. Star already here, star cannot come, here should be filled. There are many clues given. Answer is this symbol. Okay, pseudocode. Right, so guys, so they're given around 7 questions, 6 to 7 questions we can say, because in this discussion, one question might be asked in engineering maths or it will comes under aptitude, vice versa. Okay, so 6 to 7 questions are given and these are easy to moderate only for you. Right, so next verbal ability discussion will be there, so please wait for that.
Right, students, in verbal aptitude, they have tested 4 questions. Straight away, let me start with the first question here now. He did not manage to fix the car himself, So he dash in the garage, right? When I was talking in the class, how do you begin a sentence and how do you end a sentence like? If one of the clauses is in the past tense, the next clause also should be in the past tense. And you find here students like, did not manage. This is simple past. So is the conjunction here. The next sentence also should be in past tense. So you can easily eliminate gets is simple present tense. Getting, he getting. What kind of a language it is like? If it is getting, there should be easier at least. Was. So there is no be form of the verb. Straight away you can eliminate this one also. Now both seems to be right. Got it fixed? Got fixed because simple past, simple past. So he did not manage to fix the car himself. Look at the word himself. If he cannot manage himself, then it should be done by someone else. So therefore, got it. It means what now? The car. So this is noun and it has to be what we call it as a pronoun. So therefore, this one will be the right choice and this cannot be, which means, so he got it fixed by somebody. That is the meaning here, students like. I suppose everyone has attempted this question, right? We'll go with the next one now. Very simple question, students. Come on, here we go. This is an analogical question, vehemently taught in the class. Analogy is nothing but making relationships, building bridges. So what is the best relationship that we can think of? Planting is to seed, just as is, double colon means just as means similar to this relationship. You are going to identify one of the parallel relationships. Fine. We can take it a relationship like this. A seed is planted. It's a collocative language, we use it. When a seed is planted, then what should be raised? That is what our question here it is now. So when a seed is planted, can I say height is raised? No, you don't raise any height. You grow. So therefore this cannot be. You lift is raising. Now what is that? This is nuisance. This cannot be the right option, students like. Temperature rises. There is a difference between raise and rise, students like now. You raise somebody, you raise a child. There is an object here, students like. Rises. The sun rises in the east, for example, if I say in the east. And there is no object here now. So this is, actually this is intransitive verb and this is transitive verb, students like. So generally you raise a child, temperature rises, not raises. So therefore this also cannot be. So therefore this is absolutely the right answer, students like. A child is raised, fostered, in other words, just as a seed is planted. I suppose everyone might have attempted this answer, students. Very easy it was. Here we go with the next one now. Yes. This one, students like, as they have introduced the recent the syllabus. I think this is the first time that this question appears. Once it appeared long ago. What is the question now? Which of the following sentence sequence, students like, in the given options creates a coherent narrative? So we have already, I have imparted in the class, narrative sequencing. So a paragraph has been given, students like, options have been given. You need to synthesize, you need to bring coherence, what we call it as now. Come on, let us just read this one and see. I could not bring myself to knock. Well, there is a pronoun here, students like. Who is I? We don't know. Let us see if any name is given in the paragraph. Let us see. So only I could not bring myself to knock. Let me just see that. There was a murmur of unfamiliar voice coming from the big drawing room and the door was firmly shut. Seems to be a topic sentence. You remember when I was teaching you topic sentence is main sentence followed by what we call it as the examples like. This seems to be, let us wait. The passage was dark for a bit, but then it suddenly opened into a bright kitchen. Have we given any reference to this one earlier? Definitely. So you cannot start that passage was dark for a bit, then it suddenly opened it into the bright kitchen like. What passage am I talking? So I might have given some reference earlier. So this also cannot be number one, students like. I decided I would rather wander, WNDR, wandered down the passage like. He decided something later on. Okay, let us see here now. First one, students like, I could not bring myself to knock. If he wants to knock himself, there has to be some consequence behind or some cause has to be there now. So therefore, one cannot be. Do we find here any one options here now? Let us see just, yes. So we can easily eliminate this option because he's beginning a sentence with one. That cannot be. Okay, fine. Let me see next one now. The passage was dark for a bit, but then it suddenly opened it into a bright kitchen now. Which passage am I talking now? There should be some reference like. So therefore this also cannot be, students like. No, that also cannot be now. Now, I decided I would rather wander down the passage. When did you decide? What passage it is? Am I right? It means it might have given some reference now. So 4 also cannot be now. Now what is left is now. Let me just look into that now. What is the sequence now? Definitely this is the topic sentence. And the rest of them have been substantiated to support. In other words, I call the other ones are supporting sentences, students. Now come on, let us see now. See, there was once upon a time. Generally we start in narrations like that. Once upon a time there was. So this is our, there was a murmur of unfamiliar voice coming from the big drawing room and the door was firmly shut. When the door was firmly shut, I could not bring myself to knock. But he didn't dare to knock the door because this is unfamiliar voice, students like now. So you find the word 2 here, then what we call it as a 1 now. That follows the next sequence is what now? I decided I would rather wander down the passage. No. What we call it as now. Come on, let me see, students like now, right? Let me just see, yes. The passage was dark for a bit, but then it suddenly opened into a bright kitchen now. Okay, the passage was opened. Then what happened now? I decided what we call it as I would rather wander down the passage now. No. So therefore it should be 2 followed by what we call it as a 1, students like now, right? And when the passage, what we call it as I could not bring myself to knock, then what we call it as I decided I would rather wander down the passage. Then what we call it as like the passage was dark for a bit, but then it suddenly opened into the dark kitchen now. So therefore, students like this is the best, what we call it as the right sequence. Yes, that is the right sequence like 2, 1, 4, 3. Right, very good now. I suppose most of you might have got the right answer, students here now, right? Let us see that, yes. Yeah, this is based on the reading comprehension, students like. I suppose most of you might have attempted this one. This is a 2 marks question. It's very easy. Let me just go through that. In a recently held parent-teacher meeting, the teacher had very few complaints about Ravi. So what are we talking about? We are talking something about Ravi here. There were some complaints about Ravi. Very good. After all, Ravi was a hard-working and kind student. Some explanation has been given about Ravi. He is a hard-working student. Very good. Incidentally, almost all, let us look at these 2 words. Almost all Ravi's friends at school were hardworking and kind too. But the teacher, so which means Ravi is hardworking. He had few friends who were also working very hard. Very nice. But the teacher, there is some contradiction going on, students, now here now. But the teacher drew attention to Ravi's complete lack of interest in sports. So Ravi didn't develop any interest in sports. In tune to that, the teacher believed that along with some of his friends, whose friends now? Ravi's friends, who showed similar to means same disinterest in sports, which means some of his friends were also not interested in sports. I suppose you got the paragraph. Very good now. Ravi needed to engage in some sports for his overall development. So till here the paragraph, the question is which statement is logically correct? In other words, which statement is logically inferred? We can look into students. I suppose you got the idea about the Ravi hardworking. Then again, like his friends, there were some of his friends who were also hardworking. Ravi was not interested in sports and his friends were also not interested in sports now, right? Now you remember students, like now when I was teaching in the class, I taught a concept called, a simple concept, students, like if you might have remembered, AEIO concept, if you might have remembered, I will apply that concept and you will get the right answer now. A, we have generally used the word all. You remember, all means what we call it as, like A means all. Other words could be all, any, every. Okay, all is equivalent to, in other words, like E means what we call it as no. E means no. So no means we can think of not a single, none. These are some of the words I have highlighted in the class. Very good. Now I means what I told you, some. In the place of some, we can use what we call it as generally, frequently, almost. We can also look into few other word students, like now few, mostly. These are some of the words we can think of. And O is what we call it as, like, right? A, all. E, no. I means some. O means some not. The same words we can think of all, any, every, each, plus not. Okay. Now let us look at the what we call it as now, because examiner has tested very clearly students here now. If you can look into the word like some, none, all, no one. Okay. Now let us see what exactly the word almost all. All is not almost, please. All means all only. But he has used a word what we call it as almost all now. So let us get the keyword almost is our word now. So where is the word almost, students, like, can you find out the word almost here now? All, any, every, no, not a single, none, some, generally, frequently, almost, yes, few, mostly. So where did you find the word here now? Very simple calculation, students, like almost. So almost all doesn't mean all, please. So therefore, I will eliminate this option, please. It cannot be this option, right? Very nice. Almost means no. This is entirely negative now. It is going against. Generally, what we say always is that, contradictory. One of the options is always contradictory. So that is contradicting the arguments now. And then again, equivalent to no one is none. So none, it's no. But there it is almost. This also not. And the right option is some. Almost, what we call it as, is equivalent to some, students. Now, am I right now? You're right? Yes. Let us see the word now. Almost is equivalent to what now? Some. So therefore, this is absolutely the right option, students, now. Well, students, these are the 4 questions that appeared in GATE that are for 6 marks. I firmly believe that you might have attempted all, and I pray that you might have got or secured a good percentage of marks. Like, God bless you, students.
Hello dear students, good evening one and all. I am Malakondaya Gandham, teaching thermal engineering subject in our ACE Engineering Academy. Dear friends, in today's exam, GATE exam, 5 questions, only 5 questions asked from thermal part. Among the 5 questions, 4 questions are 2 marks questions and only 1 question is 1 mark question. And you know, this is the first time I have been observing in my 25 years experience, no single question asked from applied thermodynamics part. No question asked from applied thermodynamics part. Only from basic thermodynamics, these 5 questions were asked. Okay? Shall I take the very first question? Right. The first question is given like this. This is one of the questions given by my students. It is asked like this. This question connected to the heat engine or second law of thermodynamics. It is asked like this. A heat engine exerts QH from a thermal reservoir at 1000 Kelvin and rejects QL to thermal reservoir at 100 Kelvin. That means heat engine is constructed between the 2 thermal reservoir limits and produces W work. Which of the following combinations is allowed? Different options are given. Dear friends, this problem, it is better to do by elimination process like this. Let us take the heat engine which is constructed to work with 2 thermal reservoirs. Let this is our heat engine. It is not given whether that heat engine is working by reversibly or irreversibly, but that is given that heat engine is operating between 2 thermal reservoirs. I can say this is the hot source is giving QH amount of heat by the time it is maintaining TH amount of temperature, that is given as 1000 Kelvin. You know, heat engine is converting only a part of the heat energy to work energy. Because low grade energy, heat energy is coming under low grade energy. Low grade energy cannot be completely converted to work energy. Only a part can be converted to work energy, and the remaining heat energy is dumping to the another source, I can say cold source. The amount of heat rejected to the cold source is QL, while the cold source is maintaining TL temperature, that is given 100 Kelvin. As we all know, while you are constructing any heat engine or any mechanical device, all these mechanical devices must be satisfying all the 4 laws of thermodynamics. The thermodynamics says that energy neither be created nor be destroyed, but one form of energy can be converted to other form of energy. It means the energy entering to the heat engine must be equal to energies leaving from the heat engine. Energy entering to the heat engine is what? QH. Energies leaving from the heat engine, W and QL. That is the energy balance equation, W plus QL. From this, the work output of the heat engine equal to heat supply to the heat engine minus heat rejecting from the heat engine. Here the QH, right? एक minute, you should be very careful while we are solving the problem in the limited space. This is the QH, this is the QL. This is the work output, right? This is the energy balance equation according to first law of thermodynamics. Now come to our problem. Look at the option A first. You try to identify whether the energy balance equation is satisfying or not. 2000 QH, you know, the work output is what? Work output is QH minus QL. QH minus QL. Here QH is 2000, QL is 750. 2000 minus 750 equal 1250. It is balancing the energy balance equation, or it is satisfying the energy balance equation. Look at the second one, 6000 minus QH minus QL, 6000 minus 600 not equal to 5500. Therefore, option B is absolutely wrong because it is not satisfying the energy balance equation or first law of thermodynamics. Similarly, look at the option C, QH minus QL, 2000 minus 500, 2000 minus 500 is not equal to 1000. Therefore, option C also not absolutely correct. Look at the option D, 6000 minus 500, 5500. It is satisfying the energy balance equation. Therefore, the option may be either A or D. But you know that no practical heat engine gives efficiency more than Carnot cycle efficiency. Once again, no practical heat engine is giving the efficiency more than Carnot cycle efficiency. First, let me decide the Carnot cycle efficiency. Carnot cycle efficiency equal to 1 minus TL by TH only. 1 minus TL by TH only. It is equal to 1 minus TL is 100, TH is 1000, 100 by 1000. You simplify this value for getting efficiency around 90%, into, of course, into 100 to get in percentage. It is 90%. 90%. Then try to find the efficiency of the heat engine with the last option. Efficiency of the heat engine for the last option. Efficiency of the heat engine for the last option 1 minus QL by QH. Okay? You try to simplify this value. Your calculator will show that more than 90%. It is giving, the last case is giving or maintaining efficiency more than Carnot cycle efficiency. That kind of heat engine is not practically possible. Therefore, option D is not absolutely correct. Now look at the option A. Option A, heat engine efficiency. Option A, heat engine efficiency equal to what? 1 minus 750 by 2000. You simplify this value for getting the efficiency around 62.6%. The efficiency, practical heat engine efficiency less than Carnot cycle efficiency, and it is satisfying the first law of thermodynamics or law of conservation of energy. Therefore, the first option is absolutely correct. I hope all of you clearly understood. Okay? Similarly, look at the next question. Try to read it. It is given for ideal gas mixture. Ideal gas mixture. It is given like this. A mixture of two ideal gases. Let us say X, right, and Y. The molar mass of the X is given. Molar mass of the X, that is molecular weight of the X, is given 10 kilograms per kilomole. Kilomole or kg mole. And molar mass of Y, molecular mass of Y, that is not the mass of the gas Y. Molecular mass of the gas Y is given 20 kg per 20 kg per kilomole or kg mole. Total pressure of the mixture is 100 kilopascal. The total pressure is given, the mixture pressure is given 100 kilopascal. 100 kilopascal. And the mixture temperature is given 300 Kelvin. The mixture temperature, T mixture equal to 300 Kelvin. Total volume means mixture volume is given. The total volume of the mixture volume equal to 10 meter cube. 10 meter cube. If mass of gas X is mass of the gas X is given 2 kg. Then the mass of the gas Y, you are asked to decide mass of the gas Y for the ideal gas mixture. You know, the ideal gas equation is what? Ideal gas equation is PV equal to MRT. This is ideal gas equation in terms of mass of the gas, but right, in terms of number of moles, because you are asked to find the mass of the another gas, let me write the same equation in terms of number of moles. It is equal to PV equal to N into R bar into T, where R bar is the universal gas constant. the PV, the P of the mixture into V of the mixture equal to N of the mixture into R bar into T of the mixture. That is the ideal gas equation for the mixture. Here R bar standard value, R bar is the universal gas constant 8.314 kilojoules per kg mole Kelvin or kilomole Kelvin. Okay. Now here the total mixture pressure given, but total number of moles are not given, but I know that the number of moles of the mixture equal to number of moles of the gas X plus number of moles of the gas Y. Okay, let me write that point. So P of the mixture into volume of the mixture is equal to N of the gas X plus N of the gas Y into R bar into T of the mixture. But as you know, the mass of the gas M equal to number of moles multiplied by molar mass. From that, the number of moles N equal to mass of the gas dividing by molecular mass. Okay, then Nx equal to number of moles of the gas X equal to mass of the gas X divided by molecular weight of that particular gas. Similarly, Ny equal to My, mass of the gas Y by molecular mass of the gas Y. Okay, so it is equal to Nx. Nx equal to what? Mx dividing by capital Mx. Small m for mass of the gas, capital M for molecular mass of the gas, plus My dividing by capital My into R bar into T mixture. Equal to what? P mixture into volume of the mixture. It is given that mixture pressure is given, the mixture pressure is given 100 kilopascal and mixture volume is given 10 meter cube. 100 into 10 is equal to mass of the gas X given 2, molecular weight of the gas X is 10, 2 by 10 plus mass of the gas Y is to be found and molecular weight of the gas Y is 20 kg per kilomole multiplied by 8.314 multiplied by mixture temperature is given, where it is given 300 Kelvin. You put that value here and simplify for getting the answer My. My calculator, you simplify this value with your calculator for getting the answer around 4.018 kilograms. That is the answer my calculator has shown. Understood clearly? The similar kind of problem we have discussed in the classroom. Do you remember? Yes. Now let's take the another question. Try to read it. It is given like this. Consider an isentropic flow of air, gamma 1.4. The variation in the flow across the cross section are negligible. The property at section 1, P1 given, rho 1 given, U1 400 meter per second. Here U1 is given in meter per second means it is not internal energy. Generally in our classroom we may be taking U for internal energy, but here based on the units you have to decide that the U1 is the initial velocity of the flow. Initial velocity of the flow is 400 meter per second. The cross sectional area at section 2 is double that than at section 1. That means area of the cross section is increasing like this. Means indirectly it is a diverging duct. That too, the diverging duct is maintaining isentropic flow. It means the duct might be perfectly insulated and all internal irreversibilities are becoming 0. Anyhow, for that particular case, choose the correct statements about U2 and pressure P2. Symbols have the usual meanings, right? For deciding the final velocity and final pressure, you need to decide whether this duct is acting as nozzle or diffuser. Okay? For deciding whether the diverging duct, this is the diverging duct, whether the diverging duct is acting as nozzle or diffuser for isentropic flow, I need to decide at what velocity the material is entering to the system. The material is entering to the system with a velocity u1, it is given. But I should know whether that u1, that is 400 meter per second, is less than sound velocity or more than sound velocity. If this given velocity u1 is more than sound velocity, supersonic flow is entering to the system, then the diverging duct for supersonic flow is acting as nozzle. Okay? But if this u1, that is 400 meter per second, is less than velocity, that means the subsonic flow is entering to the diverging duct. When the subsonic flow is passing through the diverging duct is acting as diffuser. For that, I need to decide the sound velocity. What is the sound velocity formula? Sound velocity A equal to root under gamma RT or gamma RT1. Okay? But ideal gas equation, you know, P1 V1 is equal to M into R into T1. From this I can also write P1 equal to M by V1 into R into T1. P1 is equal to mass by volume equal to what? Rho 1 into RT1. From this I can say that P1 by rho 1 is equal to RT1. Since initial temperature is not given, only the initial pressure and initial density is given. In place of RT1, I can write P1 by rho 1, it is equal to root under gamma into P1 by rho 1. It is equal to gamma, root under gamma. What is the gamma value? Gamma value given 1.4. And pressure is given, the initial pressure 100 kilopascal. Initial density, this is the initial density 1.2. So it is 1.4. Pressure is given 100 kilopascal, but it should be in pascal. That's why multiplying with 1000, dividing by rho 1. What is the rho 1 given? 1.2. You simplify this value for getting the sound velocity. Okay? My calculator has shown the sound velocity A is around 341 meter per second. This is the sound velocity for the isentropic flow. But what is the velocity which is given? Here sound velocity, my calculator has shown around 341 meter per second. But what is the velocity which is given? Velocity which is given is 400 meter per second. Is this velocity more than sound velocity or less than velocity? Definitely, the given velocity is more than sound velocity. It means the supersonic flow is entering to the diverging duct. By the time the supersonic flow is passing through the diverging duct, that diverging duct for the supersonic isentropic flow always acting as nozzle. You know the function of the nozzle. Nozzle function is to increase the velocity. Velocity of the flow is increasing from U1 to U2. Velocity is increasing from U1 to U2 means U2 more than U1. But the nozzle is dropping the pressure. Initial pressure is what? P1. Final pressure is P2. P2 is less than P1 because the nozzle function is to increase the velocity by dropping the pressure of the flow. Anyhow, the U2 more than U1. Look at the option C. U2 more than U1 and P2 less than P1. Therefore, option C is absolutely correct. Understood clearly? Yes. The remaining two problems, my friend Mr. Raju sir will explain to you. Please wait.
Good evening, all of you. Let's continue thermal questions. It is the next question, and it is a 2 marks question. An adiabatic piston cylinder arrangement. It is adiabatic piston cylinder arrangement. It is adiabatic piston cylinder arrangement. It means the piston cylinder is adiabatic. And adiabatic means there is no heat transfer. In the bracket, it is given that having no mass, it is a memory-based question. No mass means mass cannot be 0. It's a negligible mass. And cross-sectional area is given A. Cross-sectional area is A. And it is an adiabatic piston cylinder device. Initially, the piston is located at a distance of L1 from bottom and finally moves to distance of L2. Final distance is L2, initial distance is L1 from bottom. And it is a quasi-static process. It is a quasi-static process. The boundary work done during the movement of the piston is dash. Actually, it is a memory-based questions. In this question, in this PPT question, options are not available, A, B, C, D not available. So let us analyze this problem. He said adiabatic piston cylinder. Let's take adiabatic piston cylinder. He said adiabatic piston cylinder. Adiabatic piston cylinder. Adiabatic. The piston cylinder is adiabatic. The piston and also cylinder is adiabatic, right? And initial distance is L1. Initial distance is L1. Initial distance is L1. The piston is initially at L1. Let us say this is L1. And the piston moves. Piston moves and at a distance L2. The finally, as the piston is moving, the distance is L2. Final distance is L2. Let us say the piston is moving. As the piston is moving, the final distance is L2. Let us say this is final distance, that is L2. And the distance between these 2 points, let us say the distance between these 2 points, let us say this is L. Initially L1 and finally it is L2. Let us say the distance traveled by the piston is L, right? And in this problem, we are asked to find boundary work. Boundary work means it is moving boundary work, because as the piston is moving, it is moving boundary work. And moving boundary work equation, we know very well, moving boundary work equation, W moving boundary, or simply W, it is PDV. PDV equation is nothing but moving boundary work or closed system reversible process work. Moving boundary work is, this is for closed system. This is for closed system and reversible process. Closed system and reversible process. Right. And please observe carefully. This is closed system reversible process work done equation or work transfer equation, and please be careful. It is a generalized equation. This equation is generalized equation. What is the meaning of generalized equation? It is a closed system, reversible process, work transfer equation, and it is a generalized equation. Generalized equation means, generalized equation, what is meaning of generalized equation? Generalized equation means can be applicable for constant volume, constant pressure, isothermal, adiabatic, and also polytropic. Because if we apply this equation, for constant volume process, work transfer is going to be 0. Because constant volume process, dV is going to be 0, work transfer is going to be 0. And constant pressure, if you write down this equation, this is going to be P into V2 minus V1. Similarly, for isothermal, if you apply this equation, we will be getting PV ln V2 by V1, or V2 by V1 can be written as P1 by P2. Okay, anyway, V2 by V1, this V2 by V1 can be written as P1 by P2, right? And what about adiabatic? For adiabatic, if you substitute the condition and if you derive adiabatic process, P1 V1 minus P2 V2 by gamma minus 1. And for polytropic process, in place of gamma, we will be getting N, P1 V1 minus P2 V2 by N minus 1. But if you observe carefully, he said the piston cylinder arrangement adiabatic. But actually for adiabatic process and it is reversible, closed system reversible. And what is reversible? What is reversible? Reversible means quasi-static. Reversible means it is quasi-static. And also friction negligible. Frictionless quasi-static. Reversible means frictionless quasi-static. Reversible means frictionless quasi-static. In the problem he said, it is quasi-static process. It is quasi-static process. Reversible means frictionless and also quasi-static. Simply he said quasi-static. Simply quasi-static means generally it is reversible only. Simply quasi-static means generally reversible only. And it is a closed system only because in the problem whenever they say the flow is steady flow, then only it is an open system. If the flow is steady, then only it is open system. But generally without any steady flow process, it is a closed system only. It is a closed system and he said quasi-static process, that means it is a closed system reversible process only. This process is closed system reversible process only, and closed system reversible process work transfer equation is integral PDV, and it is a generalized equation. It is a generalized equation, but actually adiabatic is given, and for frictionless adiabatic it is reversible adiabatic process. For reversible adiabatic process, work transfer equation is P1 V1 minus P2 V2 by N gamma minus 1. But actually in this problem, if you see the data, nothing is given. In this problem, nothing is given. Only he said initial distance of the piston is, initially the piston is located at L1 and finally it is located at L2. That's all. Nothing is given. Nothing more than this. Simply distances are given. Simply distances are given. So we can write a generalized equation. It is a generalized equation. I can apply for any process. Any of these processes I can apply. So if I apply this equation for this problem, so now I am going to write W is equal to integral 1 to 2 PDV, integral 1 to 2 P, dV means it is negligible change in volume. dV means it is a small change in volume. dV means small change in volume. It can be written as volume is area into distance. Actually volume is area into distance, but it is a small change in volume. Therefore, I can write small change in distance. So A into dl can be written as dV, or dV can be written as A into dl, right? So in this problem, dl can be written as, in this problem, dl is nothing but the distance, change in distance. dl is nothing but change in distance. Simply, I write it as L. The change in distance, simply I can write it as L. So therefore, this is P into area into dl, integral 1 to 2 dl can be written as V2 minus VL, or simply this V2 minus V1, L2 minus L1. L2 minus L1 can be written as, simply we can write this L2 minus L1, we can write simply L2 minus L1 we can write simply. Otherwise this L2 minus L1 can be written as L. So therefore W is P into A into L. Or else we can write W is P into A into L2 minus S1. This is going to be the answer for this problem, right? Let us go to the next problem. In this problem, select the incorrect statement. Incorrect statement means it is wrong statement. We need to identify the wrong statement. Let's take one by one. First one, for a polytropic process, PV power 1.5 is equal to K is given, where K is constant. So PV power 1.5 is equal to constant. It is generalized form of polytropic process. Generally, for polytropic process, we write PV power n is equal to constant C. We can say constant C or K, whatever it may be. So generally we write like this. In place of n, in this question, in option A, n is given 1.5. General, n is polytropic index. N is polytropic index. Polytropic index can be less than 1 or polytropic index can be greater than 1. Suppose if you take polytropic index less than 1 means it may be less than 1 means it may be 0.1 or it may be 0.2 or it can be anything. Polytropic process means many changes. It may be constant volume, it may be constant pressure, it may be isothermal, adiabatic, polytropic, it can be anything. N can be anything. If you change the n value, the process is going to change. So that is nothing but polytropic process. So n may be greater than 1. N may be greater than 1. N may be 1.1, 1.2, or it may be 1.5. And generally in thermodynamic analysis, we take n value is between 1 and gamma. In general, polytropic index in thermodynamics, we consider as between 1 and gamma. This is generalized condition. This is generalized condition. This is generalized condition. But remember, generally n value is between 1 and gamma, but n value may be less than 1, may be greater than 1, or it may be 0 also. N value may be 0 also. If you substitute n value is 0, this is going to be isothermal process. Because v to the power 0, anything power 0, this is 1. So this is PV is equal to constant. N can be 0 also. N can be 0. So anything power 0, it is 0. Therefore, anything power 0, it is 1. Anything power 0, it is 1. So simply you get here you get pressure constant. So n means polytropic index. N value can be less than 1, maybe greater than 1, or it can be 0 also. If it is 0, it will be constant pressure, right? So this is polytropic process. He said polytropic process, and also PV is equal to MRT is given. PV is equal to MRT. This is ideal gas equation. So he said in this option A, for ideal gas, PV to the power 1.5 is equal to constant. It is possible. It is correct only. It is ideal gas and it is polytropic. So for ideal gas, polytropic process, this combination, it is correct only. Next, real gas obeys ideal gas. Real gas obeys ideal gas law at low pressure and high temperature. At low pressure and also high temperature. Yes, this is also correct. Real gas. All gases are real gases only. Practically all gases are real gases, but theoretically we say ideal gas. An ideal gas is a gas in which there are no intermolecular forces. An ideal gas is a gas in which there are no intermolecular forces. Or we can say intermolecular forces are negligible. If intermolecular forces between any molecules there are forces, attractive forces or repulsive forces. So these are called intermolecular forces. If intermolecular forces are negligible, the gas is ideal gas. Any real gas approaches ideal gas behavior. Under low pressure. Under low pressure, the molecular distances are very large. Under low pressure, the distance between molecules, this is distance. Under low pressure, the distance between molecules is very large, because under low pressure, the volume is generally high. This is generalized condition once again. Under low pressure, when the pressure is low, the volume is high or volume is more. It is a generalized condition. So under low pressure, volume high means the molecules are separated by large distances. When molecules are separated by large distances, intermolecular forces are negligible. When intermolecular forces are negligible, so any real gas obeys ideal gas law, or any real gas behaves as ideal gas, right? Under low pressure, real gas behaves as ideal gas, right? And second condition, under high temperature also. Generally, if the temperature is high, the volume is also high. It is also generalized condition. It is also generalized condition. When the temperature is high, volume is also high. When volume is high, the molecules are separated by large distances. When molecules are separated by large distances, intermolecular forces are negligible. If intermolecular forces are negligible, the gas is ideal gas. So under low pressure, under high temperature, real gas obeys ideal gas law. Under low pressure and high temperature, real gas obeys ideal gas law. Yes, it is true. It is true. Real gas obeys ideal gas law, low pressure, at low pressure and high temperature, this is true. This is also option B. Option A is true, option B is also true. Option C, real gas, reversible adiabatic process, PV to the power gamma is equal to constant is given. PV to the power gamma is equal to constant, it is reversible adiabatic process. Here it is reversible adiabatic process and also ideal gas. This equation is derived. This equation PV to the power gamma is equal to constant this equation is derived from reversible adiabatic process and also ideal gas equation. PV raised to gamma is equal to constant derived from ideal gas equation, because in this derivation du mcv dt is used and dh mcp dt is used, and du is equal to mcv dt, this is for ideal gas, and dh is equal to mcp dt, this is also ideal gas. So these relations are used in the derivation of PV raised to gamma. Q is equal to du plus w, and adiabatic process heat transfer is 0, and du plus w can be written as PdV. So du is equal to minus PdV, or we can write du is mcv dt for an ideal gas. mcv dt for an ideal gas. And similarly, and also enthalpy, H is equal to U plus PV. So dH can be written as du plus d of PV. So by taking dH mcb dt, that is ideal gas, dH mcb dt ideal gas, du mcv dt ideal gas, and dH mcb dt ideal gas. So ideal gas is used in the derivation of PV power gamma is equal to constant. Ideal gas relation is used. So this is valid for ideal gas only. This is valid for ideal gas only. PV power gamma is equal to constant, valid for ideal gas only, right? And let's wait and go to the option D. In option D, for ideal gas is given. Enthalpy is independent of pressure. Enthalpy is independent of pressure, he said. See, ideal gas H is equal to U plus PV. This is generalized enthalpy equation, and for ideal gas, internal energy is function of temperature. Ideal gas, internal energy is function of temperature. Internal energy is function of temperature for ideal gas, because ideal gas is given. Ideal gas is given. Internal energy is function of temperature, and for ideal gas, PV is equal to RT. Ideal gas, PV is equal to RT, where V is specific volume. So PV is RT, which means this is already a function of temperature, R is constant, this is also a function of temperature. Therefore, for ideal gas, enthalpy is function of temperature. For ideal gas, enthalpy is function of temperature. So what does it mean? Enthalpy function of temperature means, what does it mean? Enthalpy depends on temperature only. Enthalpy function of temperature means enthalpy depends on temperature only. So depends on temperature. For ideal gas, enthalpy depends on temperature. Independent of pressure, correct. Depends on temperature means independent of pressure. Therefore, this is correct. Already A is correct. B is also correct. D is also correct. So incorrect statement, wrong statement has to be option C, because this PV power gamma is equal to constant. This is for ideal gas only. So therefore, this is the wrong statement. This statement is wrong. So he is asking us to identify incorrect statement. Therefore, answer is going to be option C. For this problem, answer is going to be option C. So hope you understood the solutions, and that's all for the mechanical engineering. So this is for GATE Mechanical Engineering 2023. Right.